Yeah, so I made a short regarding this topic, Bose-Einstein condensation. And here we are going to discuss about it. So first of all, what is a Bose-Einstein gas? Bose-Einstein gas is a assembly of bosons. What are bosons? Bosons are indistinguishable particles having a spin integral or zero. So here we have a proof of it, and we are also going to discuss about the degeneracy of Bose-Einstein gas. So here you can see the formula of n epsilon is equals to 1 upon e की power beta epsilon में minus 1. So here the number of particles n हम calculate कर सकते हैं इसे integrate करके, और जिसका फॉर्मूला है हमारे पास 0 to infinity ds n epsilon d epsilon. So where dos is equals to 2 pi v by h cube 10 की power 3 by 2 epsilon की power half. Therefore n हमारा आ जाएगा ये. बट हेयर हमारे पास एक प्रॉब्लम है कि अगर हम ग्राउंड स्टेट में होते हैं तो एप्सिलॉन ज़ीरो होता है. सो हमें इसमें ग्राउंड स्टेट के लिए अलग से निकालना पड़ेगा. सो हम इसे सेपरेटली लिखते हैं, और वो भी लो टेम्परेचर्स पे हम ऐसा कर सकते हैं. सो वी हैव n इज इक्वल्स टू n नॉट प्लस 2 पाई वी एच क्यूब टेन 3/2 0 to infinity एप्सिलॉन की पावर हाफ ई की पावर बीटा एप्सिलॉन माइनस 1 डी एप्सिलॉन, where n naught is the number of bosons in ground state epsilon 0. Now from Bose-Einstein distribution of epsilon, and since epsilon for ground state is 0, so it follows that n naught 1 upon e की power minus beta mu minus 1. So if n naught is appreciable, then the denominator above must be small, meaning thereby mu must be small negative, so that mu is approx minus kt by n naught. Therefore, mu being very small, we can ignore it in the expression. Then within this approximation, the expression in bosons n is equals to n naught plus 2 pi v by h cube to 3/2 0 infinity epsilon की power half upon beta epsilon minus 1 d epsilon. अब हम यहाँ पे x is equals to beta epsilon रखेंगे और epsilon by kt. So we are at the result n is equals to n naught plus 2 pi v h cube to m kt की power 3/2 0 to infinity x की power half upon e की power x minus 1 dx. So here we are going to have this integral as I half. So yeah, so we have the nx varies with temperature. So there are certain temperatures at Tc when nex will be equal to the total number of bosons in the system n. Therefore n is approx 2 pi h cube to mkt epsilon की power 3/2 I half. We can write it as n is equals to n naught plus nt by tc raised to the power 3/2. Inverting the previous equation, n naught gives n naught is equals to n1 minus t by tc की power 3/t for t less than tc. We can identify the temperature Tc as a transition temperature below which there is an macroscopic occupation of the ground state epsilon is equals to 0. This phenomenon is Bose-Einstein condensation. It happens at temperature Tc. This phenomenon is a purely quantum mechanical, and it is the only phase transition in nature that happens in the absence of any intermolecular forces or interactions, and happens in momentum k space. We can also calculate the transition temperature as Tc is equals to h square by 2 pi mk n upon v की power I half 2 by 3. Since I half is equals to gamma 3 by 2 xi 3 by 2, where gamma is Euler gamma function, xi zeta Riemannian zeta function. We have gamma 3 by 2 is equals to under root pi by 2, and zeta 3 by 2 is equals to 2.612. So I half comes out to be under root pi by 2 into 2.612. Therefore, the expression for Tc becomes Tc is equals to 3.13 h line square by mk n by v raised to the power 2 by 3. The h line is equals to h upon 2 pi. So we conclude now the degeneracy of Bose-Einstein gas. So here we have draw a figure like this. At the condensation temperature Tc, we have NEX. Tc is equals to capital N. As the temperatures decreased below Tc, more and more particles begin to occupy the ground state at radian 0. The Bose-Einstein gas is then degenerate and we are in the quantum region. The Tc is also called degeneracy temperature for this reason. So here the topic ends. I hope you all understood it carefully. So thanks for